Hey guys, in this tutorial we're going to take a look at how to create this sort of ribbony whirlwind sort of thing. Alright, cool. So I'm just going to start by getting rid of that, and we're going to crack open a new Grasshopper definition. And so in order to do this, we are going to use a component called pop, or we're going to start with pop2D. Alright, so what this basically does is it takes a region that you give it, or a rectangle, and then it randomly inserts points through that. And so we're just going to use this to demonstrate the concept. So we're going to take those points and we're going to deconstruct them. I should probably point out that deconstruct point and deconstruct vector do the exact same thing, so it does not matter which one you do. So I'll just use a deconstruct vector for now. And what I'm going to do is I'm going to sort these points. Oops. Yes, okay. Well, see, what I could do here is I could just run these points here through the sort point component. And I'll show you what that does. If I just put a polyline through there, what that's going to do is that's going to sort all my points along their X component. You know what, that's I mean, that's cool and all, but we want to do something a little bit more interesting than that. So rather than just using this sort point, we're going to manually sort the points ourselves. And so we're going to use a sort list. And this sort list tool is incredibly useful, because what it allows you to do is plug in okay, so we could plug in, say, the X value into this K, and then our points into A. And so what it'll do is K is your, like a number by which you're going to sort. So we're going to sort all of this whole list of points according to its X value. And so then it'll, on this side, it splits out all of the numbers in order, and it also spits out all of these numbers in their sort of relative order according to this number. So basically it'll sort these points along their X direction. And so this will look exactly the same as our sort point component, except now we could plug anything into it. So I could sort them by their Y value, or if this was a three-dimensional set of points, which it isn't, I could sort them by their Z value. Alright, so before we do that though, we need to, there's a sort of pre-step, and that is going to be with the component called includes. And I'll explain this in a sec. What we're going to also grab is a bounds component, and we're going to plug, we'll just use our X values again for now, and now we're going to get a bounds, which is a domain. And I'm going to use a range component just to just to sort of manipulate that a little bit further. So my bounds is going to be my range, or the domain for my range, and then I'm going to plug in a slider here, and I'll chuck that up to maybe 20, and then I'll plug that into my number of steps. And so out on this side, we're going to get a range of values for which our points would be included in. So if there are any points between, if there are any points between 0 and 6.6 in the X direction, they'll go into one list. If there are any between 6.6 and 13.3, they'll go into another list. And then any between 13 and 19, and they'll go into a third list. So in order to, we need to turn these numbers into ranges, because if we were to just plug these straight in here, actually we'd plug them into our domain, you can see it's going to go from 0 to that number, and what we actually want is to create a series of consecutive domains. And what do you know, we've got a component called consecutive domains. So we plug this value into here, and we'll just check our output, and you can see, no, it's still doing something a bit weird, and that's because this consecutive domains has an option to sort of add the numbers to its predecessor. So it'll go 0 to 6, and then 6 plus 13, so it'll go 6 to 19. You can see it's doing that there. So what we can do is we can just turn this additive option off by right-clicking and inverting the boolean. And you can see now we have 3 domains, first one at the beginning of our bounds and the last one at the end of our bounds. Cool. So that's that. So now we're going to plug that into our domain, and the value we are going to test for inclusion is our X value. I'm going to get rid of all these panels because these are getting in the way. Alright, and like so if we check the output, it's giving us 100 values, and if we were to create a cull pattern, because that's what we wanted to do next, and we would cull these points, so it's going to do something. It's probably not going to do what we expected at first, because what we need to do is we need to reference all of these points to all of these domains, and the way we do that is by grafting this domain input, sorry. And now we're going to get 3 lists, each with all the points in that section. And what we could also do, okay, now we could use our sort. And once again, I'll just deconstruct the point or the vector, and so we sorted them into their X values here. So over here we're going to sort them into their Y's, and we need to change our A value here. It's going to be this list coming out of the cull pattern, and when we plug that in there, you'll see we now get 3 lists of ascending point order. And so now I could take these number of steps up, and we'd get 17 different lines. Cool, so that's the basic concept. So now we're going to apply this to something a bit more interesting. I'm going to apply it to these 2 curves. So I'm going to, not to the curves, we're going to apply it to a lofted surface. So make some curves in whatever shape you want. I've made them like this. We're going to set those curves. We're going to loft them together. And instead of using the pop 2D, we're going to use a pop Geo component. And so this, it does very similar thing. You plug in a piece of geometry, i.e. the surface that we created, and it populates points all across that piece of geometry. Alright, so now we're not going to, if we were to plug these values into here, oh wait, hold on, before I do that. If I were to plug these values into here, this would sort my surface, or the points on my surface, according to their X and Y direction in world coordinates. Which, I mean, that's fine and all, but seeing as we're working with the surface, we do have some additional properties that we could use to make this that much more interesting. And you'll see what I mean in a sec. We're going to use the surface closest point component, and we're going to plug in all of these points, and we're going to plug in our surface. And so now what we get is a UV coordinate on the surface. And so if we were to now take these and plug them in, so we're going to plug our UV into the deconstruct vector, and then we're going to plug our point into the pattern, or into the cull pattern. Okay, we're halfway there. Now we also need to apply this cull pattern to the list of UV points. And now if we deconstruct this vector, what you'll see, what we get is a whole bunch of lines which to some extent follow the curvature of this surface. I'll just change this to an interpolate curve so that you can see what's going on a bit better. Oops. I'll turn it off, not delete it. Where are my points still coming from? They must be from this pop geo. So there you go. Really neat and simple way to sort of create flowing lines across a surface. Now if we wanted, we could create a slider, bump this up to something ridiculous, throw it in, and we can get these really nice sort of wavy lines across our surface. And then maybe I don't want them to be so wavy, so I could just throw down a rebuild curve, plug that in there, and then throw in a slider for my number of points. And you might be saying, well, Daniel, why the hell did you do that? And that is because why the hell did you do that, Daniel, when all you could have done is just taken this number of points down? And well, sure, you might think that's a fair question, but if I take these points down, you'll see that my curves, well, they become a lot shorter because it's not necessarily creating a whole lot of points along the entire sort of curvature of the surface. So if we increase our number of points, that creates a larger range of values, and then we can go and reduce that later with the rebuild curve. Alright, so now let's take this a step further. Let's create a slightly more interesting piece of base geometry. In fact, okay, we're going to start with a cylindrical point. Alright, and I'm going to grab a range, and with that range I'm going to plug in a couple of things. So my first slider is going to go from 0 to 10, and it's going to be a multiplier for pi. Actually, no, I don't want to multiply by the pi component, I want to multiply by 2 times pi times x. That way this slider is always going to be telling me how many full or parts of full revolutions I'm going to get. Okay, and my slider over here is going to be, I don't know, maybe I'll put it up to 32. And actually what I'm going to do, you don't have to necessarily do this, but I'm going to change this to an integer slider. And I'm also going to put a multiplier down, and I'm going to multiply these two values, so that what this is going to give me is this is going to give me 10 points for every full rotation that my points will do. So if I wanted only one full rotation, there would be 10 points. If I wanted 5, there would be 50 points. Cool. So now that's going to be my angle. I'm also going to turn off this pop 2D because that's just getting in the way. And okay, we also need a radius value. And my radius is also going to be controlled by a range. And we're going to keep the same number of points, but my domain is going to be, let's see, maybe I want this to be a maximum of 100, and I'll plug that into my radius, and there we go, we're getting a list of points. And I'm going to create one more range, and this one is going to be my elevation. Cool. So let's just check that out, see what's happening. If we interpolate through all of those points, yep, we're going to get a nice curve, but that's not quite what I want to do. What I actually want to do. Okay, so what sorry, a bit of a mind jumble there. So I'm going to plug these points into this shift list component. And what shift list allows you to do is, how can I demonstrate this? Let's just create a curve over here and bring that in, and then we'll divide that curve. Actually, I won't do it with this curve, I'll make it a bit. Okay, there we go. Okay, so now if I were to shift the points in this list, and then I were to redraw the polyline, what this shift list is doing is it's changing the order of my points coming through this division. So if I shift it forward, actually this probably wasn't a great example, but it's basically these points, if this was point 0, this now becomes point 1, and this becomes point 0, so now we're drawing a curve along here. Oops. Cool. But this shift list also comes with another option, which is wrap values. So this will basically determine whether we're just cutting off part of the list, or we're wrapping it around so that this will basically have a single gap moving around the entire curve. If we invert this boolean, you can see we can just select a smaller section of the curve if we want. And that's what we're going to be using, in fact. So I'm going to, okay, that was a small detour. I am going to take this list and I'm going to shift the points in a specific way. So I'm just going to take this number here and bring it a bit closer so that I can access it. And then I'm going to use a negative as well. And I'm going to plug my negative into here, into the shift offset. And I'm also going to plug my original into the shift offset. And we should be getting 2 lists of data out of that. And so, what this is now going to give me is 2 curves. One, okay, I'll just show you. If I turn all these off, and I take a list item. Yes, so the first curve is going to be sort of the first set of points minus the last 12, and the second curve is going to be the second set of points minus the first 12. And so, what this allows us to do is loft between these. And we can create a piece of geometry. Now this hasn't worked entirely all that well, but there are ways to fix that. I'm just gonna, okay, rather than interpolating through these points, I'm gonna flip this matrix here. And now we get 2 points in 41 different lists. And so I'm going to create a point through both of these. I'm going to create a line through both of these points. And now, instead of grabbing a list item out and then plugging that in and then bringing in both our points into this list and then creating a line from point A to point B, we can bypass all of that simply by creating a polyline. So you plug, as long as you've got more than one point in a list, you can turn that list into a line or polyline, depending on what it is. Cool, so now when we loft through these, you should see something a bit more interesting once we flatten this output. Cool. Now we're getting a very nice sort of conical, almost waffle cone sort of shape. And you know what I might do actually is bring in one of my favorite components that I seem to use every single time, the graph mapper. So we're going to plug this range into here, and this graph mapper is going to control my radius so that I can create more of a, I can sort of shape my cone, do a bit more interesting things with it. So like usual, the graph mapper takes values from 0 to 1, unless you were to sort of go into the graph mapper and edit the values of it, but there's no need to do that because the way it works as is pretty damn good. So I'm going to plug in this multiplier here, and I'm going to plug in my values here. This is going to be my radius. And now, there we go, we can give it a bit more shape, do a bit more funky things with it. Alright, that was a slight detour. So now we're going to basically just reattach all of this over here and see how it turns out. Turn these off because they're just getting in the way, and let's check our interpolate curves. Ah, yes, okay, so they're still okay, so we're doing it according to the wrong closest surface, so we'll just plug that in, and let's see, okay, it's probably also going the wrong, it's using the wrong direction for our U and V parameters, so we're going to swap our X and Y here, and then we'll swap the X and Y here, and there we go. I'm going to increase my radii values. So now we get a whole lot of curves along the entire direction of the surface, and I'm going to check the rebuild as well, see how that turns out, and it's looking pretty good at the moment. What I'm also going to do now, okay, I'm going to flatten these points, and I'm going to use a partition list to create a final piece of geometry. And I'm going to partition that into sets of 2, and then I'm going to loft those together, and it looks like it's giving us a very strange result in the middle, and that's probably because we just either don't have enough points through here. Oh yeah, there we go, just didn't have enough points going through. Or what we could also do is take down this number of rotations, because that might also be impeding a little bit. Cool, so there we go, we're getting all these really nice sort of ribbons. If I bake them out just to check if there's any issues with them, this one seems to look a bit weird just in terms of its curvature and all, so I could resolve that. Well, I could either sort of take down the rebuild number, but you see if we go too low, actually it does create some pretty interesting results, like, you know, I quite like that, I think that would be pretty cool, but no, I'm going to do something else actually. I'm going to use a mesh surface component. I'm going to plug my surfaces in, and then I'm going to drag out 2 sliders. I'm going to set one of them to a maximum integer value of 5, and the other one to a maximum integer value of 100. And I'm going to plug that into my U and V. Oops. I'm just going to make sure I've done that in the right order that I wanted. Yes, I have. Cool. And so now I'm going to increase my count again. 30 still seems a bit low, especially if we're working with upwards of 1,000 points for the initial part. Maybe I want it there somewhere. And so now the reason I meshed these was so that we could use a Catmull-Clark subdivision. Basically, if the geometry coming out of this loft is looking a bit weird and twisted and just not very good, this will help clean it up a little bit, because it's just a smoothing algorithm. I probably haven't touched on this, on what the Catmull-Clark subdivision does too much. I will have to do that at some point. But there we go. There's our result, looking quite a bit cleaner. And yeah, there we go. So let's just see what we can do to make this look a bit nicer. Maybe I want to, okay. Kind of want to shape it, yeah, kind of like that shape. I'll drag the radius up a bit. I'll increase my elevation. Take my rotations down. Oh, no, that's not good. Maybe I'll put it up to 4, in fact. Put a few more points in there. Decrease my number of ribbons. Yeah, there we go. Something like that. There we go. So that's been a tutorial on how to make these weird sort of ribbony things. Have fun with it.